Welcome to myprojectbazaar.com. Let me discuss about the project human identification based on extracted gain features. Let me see the concept of the project human identification based on extracted gain features. In this project we propose a new method to classify the human by their gain features. The gain feature is modified by their walking and their wearing apparels and their shoe type and they are carrying objects and their walking speed are differentiated, but their trajectories are same for every human person. So we propose this project. We use the Cassia-B database to perform this process. Silhouette images are collected. Silhouette images are proceeded to the process. In this project we performing the feature extraction by PCA, that is principal component analysis feature extraction method, and we also perform the DCT, that is discrete cosine transform feature extraction, and the fused features are performed for classification. We classify the human recognition by KNN, K nearest neighbor algorithm are used. In our project human silhouette are collected and that give best performance. Because of using silhouette is that is no human interaction to perform this process. In this project we propose two methods and we also fused the features extraction methods, and we also calculate the performance of the features and classifiers. The classifier performance is calculated and that is converted into percentage format, that is also displayed, and the calculated time are considered for separate features. Feature extraction values are calculated in time and it's also displayed. Use of PCA feature that extract the eigenvector values, that extract the eigenvalues and perform the eigenvector values. That eigenvector values are used as the feature values. In DCT feature extraction, cosine transform are calculated for the given silhouette. Silhouette in the sense that consists the black and white image. So we must perform the morphological operation to remove the unwanted pixels, and we also use this performance for the edge preservation. We must preserve the edge of the person, so we must use the morphological operation, that is morphological open and morphological close, is to preserve the edges of the human silhouette. This human silhouette images are collected from infrared cameras, but we used human silhouette sequence of images. This sequence of images that has low decibel and high decibel values. If any one images, that also the result is increased performance, that gives the best result and best higher accuracy. Gain features are performed well, that is also complex to perform the feature values. Gait offers the ability to identify people a distance whenever biometric or obscured. Biometric feature images like fingerprint and other images are used for human interaction, but in the Gait in the sense it doesn't need Gait interaction or human interaction. Gait features are vary from human to human. Based on this the project is done. Let's see the flow of the project human identification based on extracted gained features. In this project we performing the project with the use of human silhouette. This human silhouette is extract the gained features from the human images. These human images are extracted from infrared cameras. We use the human extracted silhouette images. Initially that is the registration process. Registration process in the sense load all the silhouette of all the person's images. Each person that has 11 up to 11 views of the silhouette. That all the silhouette images are loaded and we perform the morphological operations. Morphological operation is in the sense it preserve the edge of the human silhouette. Human silhouette are sometimes affected by some edges, that is removed and preserve the human edges. and then we perform the DCT and PCA feature extraction method for all the images. We load all the persons, all the images are loaded, and then we perform the morphological operation. Morphological operation performed images are used for feature extraction. Feature in the sense PCA feature extract the eigenvector values and DCT feature extract the cosine transform value. These two features are fused, and fused features are called trained feature because we extract the feature for human silhouette of all the persons. That consists up to 2 to 3 persons of images are trained and stored in the table. Table in the sense in MATLAB it's stored as a mat file format. And we also perform one query sequence image. We input one person silhouette. This silhouette is get by runtime of the programmer. Then we perform the morphological operation. Morphological operation that also perform for the query image and also the database image. Query image is performing the morphological operation to preserve the edge of the silhouette. After that morphological operation, we perform the feature extraction for given query image. That is also done by PCA and DCT feature. PCA feature extracted and DCT feature extracted features are stored before that it fused together. These fused images are called query feature. This query feature is stored in a mat file format. The mat files are stored in the MATLAB. The query image and trained images are matched by KNN classifier. KNN classifier in the sense K nearest neighbor classifier match with the query image and training image. Query image is matched with any one of the training image feature. The matched feature is point out that we also perform the labeling process before that. We set label to each silhouette process. Group of silhouettes are labeled into 1, 2 or 3. The query image is matched with any one trained image. Then we extract the label of the matched trained feature. The label is returned as identified person. The person is wearing apparel, that is the person wearing a bag or the woman wearing a bag, like that. Let me discuss the running procedure of the project. Human identification based on extracted gained features. These are the function used in our project. Right click on the main.function function and press run file. This is the executed window. Initially press extracted features of training set button. It loads all the human silhouette and extract the features in the first and second table. First table extracted DCT features and the second table extracted silhouette features, that is PCA features are extracted and displayed. We used 53 set of silhouettes that are extracted features, and that features are stored in this table, and also these features are fused together and stored as a mat file, that is stored as a training feature.mat. And we can give the query image by pressing the load button. Press load button and select any one silhouette from there. I am selecting the M001 and press open. Then perform pre-processing step. This given query images that has some blurry noises, and we remove that by pressing pre-process button. Pre-process button remove the noise and give the clear picture. Then perform the feature extraction step. Feature extraction step extract the features from the human silhouette, and that features are displayed in separate table. Initial features are displayed in first table, then the PCA features are displayed in second table. After the feature extraction, that displays the message as test features are extracted, like that message, and then we perform the further process because it disturbs the running procedure. After the feature extraction, the features are fused together and stored as a test feature.m file. Then we perform the KNN classifier that classify the given image from the database image. Press the KNN classifier button that displays the message Marin carried a bag in shoulder image, that classify by stored image. We can also use this image from the out of database. It also give them result for non-trained image also. Then we perform the performance of the given project. Before that, it displays the time taken to the project. It taken 0.03 seconds, and it also displayed that 0.04 seconds for DCT feature extraction. Then perform the feature extraction. After that, it gives the performance. The performance is 100%. Then we can also view the ROC curve for the given project. ROC curve is displayed in the separate window, that is displays the ROC curve. This is the overall project concept that classify the performance, and we get the performance percentage in the edit box. We also get the KNN classifier performance. The initial table displays the DCT feature, and the next table displays the PCA feature. Classifications are done. Then press exit button. Exit button close all the opened window in the running project from the MATLAB screen. Thank you.